Hi class, this is Ms. Schwans, and I'm working on number 8 on chapter 8 practice test. These are one of the hardest ones that you cannot use the calculator for. Whenever they ask you for the sample size, you have to get down and gritty and you have to use the formulas. So you want to obtain a sample to estimate the population proportion. That's important. This is a proportion problem. There's a particular problem that's used to find sample size for proportion problems. There's a different formula that you need to use for mean problems. So if they're asked to estimate a population mean and you're trying to find a sample size, there's a different formula for that, okay? So I have written down the formula that we need for population proportion sample size. Okay, based on previous evidence, you believe that population proportion is approximately 67%. So that we're going to put that in for our p hat here. If they do not provide that, then you go ahead and put 0.5 in. If they say there's no prior evidence that we have, then you put 0.5 in. 0.5, what it does is it maximizes the value of n because it's okay to worst case scenario, this is p hat is 0.5, and that would make this n the largest value that it could be. It's okay to overestimate the n here, okay? But it's not okay to underestimate, because we need a minimum number of people to sample, and always oversampling is always all right and acceptable. The more people you can sample, the better that estimate is going to be, the more accurate, like just the better it is. Of course, ideally you'd ask the whole population of interest, but you just don't have time and money for that normally. So it's okay to overestimate this in, but not underestimate it. So that's what's the idea between, let's just assume it's 0.5 if we don't have prior evidence. So the biggest thing, so we have the p, this is our p hat right here, okay, that we're going to be, of course, we have to plug it in as a decimal. And then the 0.01%, that is the e, we have to turn that as to a decimal as well. I'm going to plug it in for e. So we just need the p hat and the e, and then the one last thing that we need that's actually really hard to kind of find is the z alpha over 2. I'm going to show you how to find it, and then I'm also going to show you like the shortcut that I'm going to give to you to find it. But what z alpha, okay, let's write this down. If we have a 95% confidence interval, alpha is the leftovers. So if we're 90%, 95% confident, what's left over? How much are we not confident? And that's the alpha equals 100% minus the confidence level. Okay, so alpha is 100% minus the 95%, which would be 5%, okay? And then so z alpha over 2, and I always plug in the 5% as a decimal, so that's 0.05, and sometimes I actually make the little humps so that I don't make any mistakes there. But it's z of 0.05 over 2, and that is z of, if I divide that by 2, it's 0.025, okay? So this is the actual value that I'm trying to find. Now, here's a little formula you can use. If I have z of any value, what they really mean by this is they mean find the z-score such that I have X amount of the space under the curve to the right. Find the value along the x-axis, number of standard deviations above the mean or below the mean, such that I have X amount of area under the curve to the right. That's what we're actually doing when we do that calculation. So to find that, we have to do inverse norm, and then we have to do the area under the curve to the left. It always has to be some more high-tech calculators will just ask you, hey, do you want to put in the area to the left, or do you want to put in the area to the right? So they're real sophisticated. And so if you have one of those calculators, you can just choose area under the curve to the right and just put in 0.025. You're done. Well, you actually have to put in the mean and standard deviation as well, I believe. But area, my calculator is a little old-fashioned, so area of curve, area to the left. I have to put area to the left, okay? So I have to actually put this, all of this area in, which would be 1 minus x. So I always do 1 minus x, and then you always have to put the mean and standard deviation in. And so that's what is going on with this particular problem. So if I plug in this 0.025 in place of my x, you're going to have inverse norm 1 minus 0.025, 0 and 1, and then you're going to have, that's going to be your this z-score that you need to plug in for this value right here. Hi, Danielle. Hi. I'm just finishing up a little recording for another student really fast, and I'm almost done, but it's number 8 on chapter 8 practice test. So if you want to, you can kind of follow along on the rest of this one.
Okay.
But what I did right now is I was saying that this problem is a population proportion problem. So we have to, and they're looking for the sample size. So we have to use this formula and be very careful, because for every problem in chapter 8, you have to always ask yourself, is this a population mean they're looking for and talking about, or is it a population proportion? Because if it's a proportion, there's particular formulas and a particular calculator, test that you have to run. But if it's a population mean, there's a different test and different formulas that you have to use. So you have to be very careful with every problem in chapter 8. This one was a population proportion, so I used this formula that's for population proportions. I found that the p hat was your 67%. And we have to put it as this decimal. We found the margin of error. We said the estimate has to be within 0.1. So whenever they have that word within, whatever comes after that word within is your margin of error. So I wrote that as a decimal. So actually it's very confusing because it's a percentile that's already written as a decimal. So you still have to just move the decimal twice to the left. So this is going to become, as a decimal, it's going to become 0.001 that we're going to actually be plugging in for the E there. So I'm going to rewrite this formula. I'm going to plug in the 0.67 for our p hat, 1 minus 0.67. And then I'm going to plug in for the E, the 0.001, and the Z alpha. You didn't get to see how I calculated this, Danielle, but I plugged in what the alpha is, which is what is left over. If I'm 95% confident, then what's left over? 5% is left over, or I think about it, what I'm not confident in is 5%. So that's how I get my alpha is what I'm not confident in is 5%. So I plugged in 5% as a decimal into Z alpha over 2, and that gave me the Z, so 0.025. Then this notation means find the area under the curve such that, or not find the area under the curve, find the value, the Z-score along the horizontal axis such that there's 0.025 area under the curve to the right of that. So to do that calculation, a TI-84 calculator, usually you need to do inverse norm 1 minus whatever value you have for Z sub number. If you have a Z sub number, then you do 1 minus that number because you need the area to the left and not the area to the right. And then you put 0 and 1 because that's the mean and standard deviation of the Z scores. And then that will calculate for you the Z score that you need. That's one way to do it. And let me just do that calculation really fast, or actually, so let me show you how that would be done. It is stats, distance plot, normal distribution. I put 0 as my mean and 1 as my standard deviation. And then I'm going to, in parentheses, I'm going to click now on the inverse function. And then I'm going to input 1 minus the 0.025. And that is the score that I want, the 1.95. And to 3 decimals, I guess it would be 1.96, well, 1.9 or 1.96. So that is the answer here. Let me get back to that screen. 1.96 is what we want. So this answer, Z alpha over 2 is 1.96. So let me go up where, so here's where some students make mistakes. Z alpha over 2, we're plugging in for that whole thing, Z alpha over 2, 1.96. And then we have to square that. So now that is all. Nice to have you, Michelle. I'm sorry, I'm finishing up one little video for my student, and hopefully you guys can like find this valuable as well as I'm going through this problem. Okay, now be careful. A mistake that I think students might make with this problem is what you have to make sure that it's just this 1.96 over the 0.001 and square that. You don't want to enter this, and this, and then square everything, because it's going to think everything is being squared, which is not what we want, of course. So sometimes I put this portion in first just to make sure, okay, I just squared just this, and then I multiply by the other stuff. So let me show you how I do it on the calculator, because it is crucial. Like if we don't put this in the calculator and it doesn't interpret this correctly, we're not going to get this right. So 1.96 divided by the 0.001. Okay, so I take that answer, and oh my gosh, this is going to be a really big answer. And I think Michelle was saying that she actually had a really big answer for this as well. And I think this is going to be a big answer. So if I want to square something using class calc, I can just do shift 6. And then I put a 2, and then it squared it, which is humongous, but I'm not quite done with this problem yet. So then I times by 0.667, and then I times that by 1 minus 0.67. I believe it was 0.67. I still get a humongous answer here. Michelle, weren't you saying you got a really, really big answer for this problem at 1.2?
Yeah, I got 870 something thousand.
Yeah, this is like, yeah, this is a humongous answer, but let's see what they want. I think I didn't. Let's see. Okay, so, and then another thing is make sure that you guys know that like this needs to be rounded to always up. So this would be 84937.8. So let's see what it is. Yep, it's exactly, no, it's a little bit off. Yeah, the same thing, it's a little bit off.
What I found is that top number, the Z sub alpha number, expand that to 4 decimals, and it should be a little closer to, oh, your number's bigger.
My number's bigger. Okay, so maybe that's what we need to do. Maybe we just did not keep enough decimal places. Let me calculate that one more time. It was the invert, no. Okay, let's be more accurate with that number. I really wish it wouldn't do that. Like, okay, 0, 1, and then normal CDF. Some of these are really not so great at, okay, normal CDF, inverse, okay, so then we do, it was 1 minus 0.025 in point. Yeah, so they probably want the, what, 1.9599?
Yeah. I went all the way to 1.959996.
Okay,
But
1.9, 1.5, 99663. Okay, I'm just gonna try to do as much as say 639.
yeah, that put you at 345. When you went to 3, their number was 849,344.
Well, yeah, I think they're right. I think that's right. I think that it was 4-4. Let me see where it is. Where'd it go? Yeah, because now I'm getting 84934. It would actually be 7347. But let's see. Yeah, and they're 344. So they're still like a little bit different than me. I'm wondering 0.67, 0.67. I didn't get that wrong.
What if you take the 5 off? I'm wondering, does your number still get bigger?
Let me see if I take the 5 off.
No.
No, it's not getting, oh, it's not getting smaller. It's staying
Okay.
about 4.6,
Yeah, that's weird.
right? It is weird. I
Do
wonder,
you have that Z chart for the
yeah, maybe
percentage?
that's it. Maybe they're using a Z chart. Like, I feel like they would even like the normal typical thing would be to like round this to 1.96. So
Yeah.
I am surprised that they're getting this slightly different answer from us. I might email them about this particular problem because I'm not sure why. Yeah, I mean, with us being so accurate to so many decimal places,
Yeah.
I wonder if it will be like, oh, this is a close enough answer, because that might be that
Oh
might
yeah, sometimes it does that.
yeah, let me see, 8. And I want to go all the way back. Well, mine was really different when I had 1.96. Oh, they said do not round but they said keep the critical value, which is this Z alpha over 2 to 3 decimal places,
Yeah.
which would be the 196, which is, I might have to email them because I'm not sure why, what's going on with this. 96, which would be 377.
Yeah, that's weird.
Yeah, this is weird. And I don't think it's going to accept it. Let's see. 84937. It should be 8. And I doubt, yeah, it's going to be too far off. Yeah. All right, I'll have to email them about this problem because this is not, we did it right. I don't see what, yeah, it's just, it's probably like a rounding thing for them. Maybe
Yeah.
they're using a chart that's a little different, that has numbers that are a little, I don't know. All right, so anyways, you might have to email me about this problem and I might have to take this problem off. So we'll see about this problem. Okay, I'll stop recording.